And how big is a big ship? So to get a general sense of how big a ship is, this is a Boeing 747, and this is the size of a big ship, almost 400 meters. This is bigger than 400 meters. And to get a better sense, this is the map of KAIST. And I think this is the creative learning building. And this is the mechanical building, I think. And a big ship is almost the size from here to here. So yeah, big ships are quite large, as you can see here. So the larger the size of the ship, the higher the transportation efficiency. So what this means is that bigger ship basically can carry more cargo at the same time, so it's much more efficient. So the capacity of the cargo is proportional to L3. L3 here means the cubic length or the volume. So yeah, the greater the volume, the more cargo the ship can carry. And the ship resistance is proportional to L2, which is the area of the ship. And we're going to talk about what actually is ship resistance later on. So yeah, since ships are so large, it is impossible to make a prototype and then test the prototype. So the first prototype will be the final product. As a result, usually during a shipbuilding process, we make a small scale model of the ship, so maybe like a 1 to 1,000 or 4,000. No, I think even smaller, yeah. Ship, and then we test it on the water beds. Okay. So one way we measure the power of a ship is this quantity called power weight ratio. Actually, in here it's given 9.1 ton per horsepower, so it's more accurately weight power ratio. So what does this actually mean? So this means that, for example, say if our power weight ratio is 9.1 horsepower per ton, it outputs 9.1 horsepower for every ton of its mass. So the larger the power weight ratio, the greater the ability of the engine to move its weight. So higher power ratio equals to better and faster ship. Okay, so there are a lot of resistance that a ship faces. So for example, when it goes through water, there are viscous forces from the water, there are water waves hitting the ship. So there are a lot of different kind of sources of resistance in the ship, and there is no scientific process. Before there wasn't any scientific process through which we could estimate. So it was mostly an art. So we gathered data from empirical evidences, so from observation rather than theory. And that's how one would predict the resistance a ship would face. And estimating ship resistance is really important, uh, given that it can give us a good estimate of the fuel cost, etc., for a voyage. So additional difficulty also includes sea conditions. So a rough sea can have a largely different resistance to a calm sea than cargo loading condition and degree of fouling. Fouling here means that when a ship goes through the water, different aquatic water bodies can attach to the side of the hull. So this can create additional friction. So you guys can understand why it is difficult to estimate these kind of variables in the ship resistance calculation. So type of resistance here includes frictional resistance, wave making resistance, eddy resistance, and air resistance. So frictional resistance is quite straightforward. It is due to the motion of the hull through the viscous fluid, and then here the viscous fluid is water. So wave making resistance, this is a little loosey over here. So what this basically is that, so when a large ship is moving through the water, it usually creates a wave behind it called the wake. So the energy to uh, make this wave comes from this wave making resistance. So this is basically the energy that must be supplied by the ship to create the wave behind it. And eddy resistance is due to the energy carried by the eddy shift. So it's basically the more turbulent the water is, the more eddy current it creates. So as a result, a very streamlined ship design will reduce the turbulences in the water. As a result, it could reduce the eddy resistance as well. And air resistance is due to the aerodynamic drag uh, above air resistance is the resistance faced by the part of the ship which is above the water. So yeah, I guess it's pretty straightforward. So wave making resistance, the energy wasted in making the wave or the wake, and the eddy resistance sums up to be the residual resistance. And submerged bodies also experiences frictional drag, and due to this frictional force, this creates a pressure on the submerged body, which influences the pressure distribution of the ship. So, as we might know, the shape of an object largely determines the drag experiences. So in here we have different shapes and the corresponding drag coefficient. So the greater the drag coefficient, that corresponds to a greater frictional force experienced by that shape. So if fluid is flowing from the left to the right, the objects here will experience this coefficient drag will face these drag forces, and the smallest drag forces experienced will be by the airfoil shape, the airfoil shape over here, which has the lowest drag coefficient of all shape. That's why if you notice, airplanes are kind of designed in this airfoil shape as well. Even the airplane wings are designed in this shape to reduce the drag coefficient. All right, so our next topic is Kelvin wave, and so Lord Kelvin, as we know, he is attributed to have studied a lot of different physical phenomena, such as the temperature, the scale, Kelvin scale as well. So one day he was thinking like, oh, when ships and ducks, they move through water, it created this pattern in the water, and he was studying this pattern. And what he found out is that usually for moderately slow moving object, the wake pattern is formed in something along this manner. So this point here is the vertex, that is the source of the wave. So that could be the ship or the duck. And then it creates this envelope. And this envelope is is about 19.5 degrees from the path at which the object is moving. And inside the envelope, it creates this curved turbulent waves, so transverse waves inside it, and the superposition of this wave inside this envelope creates this pattern. This is true for most cases when the object is moving at a moderate speed. And then the professor already spoke before about the importance of bulbous bows. So what is actually the bulbous bow? It's this protruding, strange kind of object over here. So what this does is it modifies how the wave interacts with the ship. So when a ship moves forward, it has this part over here. This is called the bow. So this part over here, this is the bow and this is the bulb. So if we were to isolate this part over here, so taking a ship with only a bow and taking a ship with only the bulb, we would have different wave created, no, different wave associated with each of it. So this wave created here can create additional friction, opposing forces to the ship. So having both of these object, bow and bulb, what this does is this makes these two different kind of wave, and the addition of these two different waves cancels each other out. Just like a noise cancelling like this. So what this does is this makes the incoming wave much more calmer. So this improves the stability of the ship, it improves the fuel efficiency of the ship, and also it reduces the drag of the ship. This is a video of how ship resistance is tested in the University of Washington.
Cannot see the Adib, we cannot see the video.
Oh. Oh, can you see the video now?
Yes.
break.
Yeah, so that was the end of the student lecture. So in the video, what we noticed was that um, the the ships are not tested like in their full scale size. So in that video, the ship that they were testing was quite small. And so yeah, that's the end of the lecture. I hope you guys enjoyed it. Thank you.
Great. Any question to Adib? No, then we can try again with Bracket for discussion session. Please turn on your audio, please.
Yeah, I turned it on. Can you see my screen?
Yes.
Okay. So actually, I was under the assumption I prepared the discussion for chip resistance and powering. So we will do that. Yeah. So. Okay. So this just to get introduced. There are two sources of resistance to ships from wind and waves, and there are three kinds of three main components of resistance in two ships. The first one is, as you can see on the slide, frictional resistance, and then residual resistance and air resistance. So I was thinking if some of you guys just like say something about these three types of resistance: frictional resistance, residual resistance, and air resistance. So what the source of the resistance here is, and what how much they contribute to the overall resistance in two ships. So someone can start with frictional resistance.
Oh, I guess the waves hitting the ship could be a source of resistance. For frictional resistance, the resistance that the ship experiences when it moves past the water.
Can you speak louder a bit?
Oh, sure. So for frictional resistance, the viscous resistance that the hull experiences when it moves past the water is probably the source of the frictional resistance.
Okay. How much do you think it contributes to the overall resistance to ships?
I think it's a large, it makes a large portion of the resistance. Not sure about the number.
Oh, okay. So frictional resistance, as you can see on the screen, it depends on the size of the ship underwater. And as Adiva said, it represents about 70 to 19%, so that's a large chunk of the total resistance for low speed ships. And the next one is residual resistance. Anyone can say what it is, and also just give an estimate of how much percent it contributes to the total resistance. Okay, I think I should go on with this. So it comes from the wave resistance. So that refers to the energy loss caused by waves created by the vessel and viscous pressure resistance, and it's about 10 to 25% of the total resistance for low speed ships and 40 to 60 for high speed ships. And the next one is air resistance. So I'd assume you can guess from the name, it comes from, it's a small percentage of the total resistance, and it can be as high as 10% for loaded containers in headwind. The next one in ship resistance is techniques for measuring. As you can see, there are many types of measuring techniques: traditional, regression-based, direct, model test method, and CFD. CFD stands for computational fluid dynamics, and here is a discussion topic. So what do you think is the major factor in deciding which of those methods to use to determine the resistance in ships? Hello?
I think safety is for residual resistance, because residual resistance is big ship is residual resistance is bigger.
Oh, okay. So the question, I think, if you did not get it, is so like the operators of the ship, they have to know somehow how to measure the ship resistance, the resistance to the ship, so they can use the methods listed on this slide. And what's your opinion on the type of those provided here? What do you think is the reason to use like one or the other from among those?
I think traditionally, they use like the top one traditional and probably direct model testing to get an empirical data for how ship resistance is to be calculated. And I think in modern times, they are also coupling that with computational fluid dynamics and regression-based algorithm to further improve on.
Oh, okay.
And I think that the CFD can be used for the early design stage of, or using for the early ship design stage, because they cannot make the all kinds of model for the various design. And for the later stage of the design, I think they use a direct model or the traditional way to figure out that the realistic resistance that the CFD cannot calculate it.
Yes, I agree to Kian's opinion. When we design the when we set the ship's design, first of all, we calculate the resistance by CFD, because by using the CFD, we can save the time and cost for the estimating her resistance compared to the model test. Finally, we can use the model test in the model basin. That is so expensive process because we have to make the model scale the ship, and we have to prepare the model basin. So it is so expensive process.
Okay. Okay. Yeah. Good. So this may also contribute to the decision to make to which to the decision we have to make to use which of the methods provided. The accuracy, so they have different accuracy levels, and also funds available. So I think to use safety, maybe like you have to use software, so it may be a bit expensive, but I'm not sure if it's right or not. And also there is the degree to which the approach has been developed. So if you take safety, it's a recent method, so the time also determines which method people have been using throughout, like, yeah, the usage of ships. So this is for ship resistance. So we'll go to propulsion. So this is for ship powering. There are many types of propulsion. I think around 11. These are, you can, as example, take diesel, wind, nuclear, gas turbine, fuel cells, and biodiesel fuel. And also there are different marine propeller types. These are just to mention: fixed pitch propellers, contra-rotating propellers, controllable pitching propellers, and water jet propellers. So these are the things, the type of propellers people are using in ships these days. So the next question is, what kind of propulsion forms do you think would be best for the future? And also you can mention the pros and cons of the types of propulsion you think is best for the future. So I'll repeat the question if you have not got it. So we have seen the types of propellers above. So diesel, wind, nuclear, gas turbine. You can just choose from this or come up with some other. And also what kind of propulsion among those, and also maybe if there is another one, do you think would be the best for the future? And also you can just mention the pros and cons of the type of propulsion we chose.
I think in the future, battery technology is so developed. So
Okay.
actually in order for the electric propulsion method to be commercialized, the core the battery technology is very important. In the future, battery capacity will be very increased to operate a ship for a long time. So I think compared to the other type propulsion system, that electrical propulsion system is most popularized.
Oh, okay.
I think in the future, probably electric propulsion will be used on small boats, on small excursions. So, for example, within cities, so in the rivers, those kind of small ships will probably use electric propulsion. And I think for long haul transportation, I think hydrogen fuel could be a replacement to current diesel and gas propulsion system.
Okay.
I also think that electrical propulsion is not good for long travel or container ship because of the weight of battery. So I think nuclear or others are suitable for container ship. And also, as Dip said, the small ships, most of them, I think they will change it to electrical propulsion because of environmental issues.
Yeah.
And I think I I hear that the electrical motors have a high torque for the low speed, so we may use electrical propulsion for only when the ships start to move from the port, and, and ships are going into the port to speed up and that doing a and move in the short range. We may use both the diesel or mechanical propulsion with the electrical propulsion.
Okay. Yeah, good. Yes. So, as you have mentioned, there are nuclear. Also, there I think would be used in the future. Also, this one, the one of the main consensus seems to be electric propulsion systems. So it overall efficiency, it increases the ship, but also reduce carbon footprint. So that's a pro. And it may also have disadvantages, as Yun Sang mentioned. Yeah, they're not good for really long journey. So also it may not be the energy conversion, as you can see here. The energy conversion efficiency may not be as high as the other ones, the conventional system. And also the cost may be a bit expensive. And also there needs to be new training for ship crew member, as system is going to be completely different from the conventional ones. Yeah, that's it for today's presentation. And thank you for participating.
All right, thank you very much. Because we have 5 minutes left, can you show us the diagram you've drawn for the accuracy method, resistance prediction method?
Okay. This one?
Right, yes. Yeah. The top is traditional
And standard series?
Standard series. Right hand side, the regression.
Regression based, yeah.
Right, regression analysis. Right. Two of them are using old data.
Yeah.
Right. So you can say we use our experience before.
Yeah.
So two methods that are slightly different, but basically we are using old data from series test result or data itself. Right? The regression also use data, but data is probably coming from series model test or the real full scale data coming from C trial. Right? But anyway, two are coming from old data, and the left CFD and model test is coming from real data, now data or present data, right? So not old data. So you can separate out this way.
Okay.
And if somehow there are different methods you already shown us, but if as a designer, if you can predict well because of many reasons, because you have many experience before, you have a lot of data coming from the other person. But anyway, if you are capable of predicting the speed within allowable range, then you don't need to have a CFD, you don't need to have a model test. Right? As Woo Sang-min says, model testing is expensive. You need to have a towing tank, you need to have a model itself. Also, it takes time, months of time. right? Several months. So it is expensive. So if you are not sure to can predict the speed and power within the allowable permissible range as a designer, then you don't need to do it, the model test or CFD anymore, right? That is a usual case. But the contract are usually saying you need to have a model test, you need to have a CFD. But in that case, you do as say to fulfill the contract, not for the design, right? Because you already had a kind of exact or accurate prediction, right?
Yeah.
So, but if you have a very new ship, first kind, first in the world, then you don't have data. Then you need to have many times of experiment. Okay, that's enough for today.
Okay.
See you on Thursday.
Okay.
Right? Oh, this is Thursday. Next week. Right now.
Next, yeah.
Right now.
Bye.
Next week we have a exam. Oh, so we don't have a class. Okay. And midterm exam, did I provide you how to term exam?
No.
No, I did, but I will distribute again.
Oh, okay.
So how to midterm exam, right? But you can find out while, right? Bye now.
Bye.